First of all, I'd like to thank Dr. Smith-Bindman and her colleagues at UCSF for inviting me to speak at this virtual conference. We'll be talking about the ACR's dose index registry, how it was developed, how it's used, and how it can be useful as a tool to determine how a facility is performing with regard to the amount of radiation used for imaging studies. Next slide. The dose index registry was born, you might say, out of some observations that came during a NCRP study in which they showed that there's been a tremendous rise in the use of CT and in nuclear cardiology. And that spurred a lot of interest among various places within both the radiology community and outside the radiology community. And before that, actually, we had asked an interesting question. Next slide, please. In the journal of the ACR, and that is that what is the national average for a particular exam? Well, the truth is that we didn't know. Now, we knew that what the limits might be, that kind of thing, but we actually had no real data to determine that what is the real value. And so from that, the ACR had formed a number of different registries, and the one that we're going to speak about today is the Dose Index Registry. It was launched in May of 2011. It collects dose index data automatically when the folder is closed at the CT scanner. The data then get transmitted to another device and then onto to the registry itself. It's fully automated, and it uses standardized procedures such as the DICOM dose report, RADLEX terminology, and we follow the IHE REM profile. So the goal here is to establish national benchmarks and practice patterns for those that participate in the registry. In addition, this will allow an institution or an individual to be able to see where they are with respect to machines in other parts of the country, or for that matter, part of the world. Next slide. The whole process then is shown here. First of all, data are taken from the scanner, and then they are transmitted to the DIR. Then benchmark reports are produced, and the facility can compare their data to other places perhaps in their state, their city, the world, or the nation, the whole registry. So as I mentioned, next slide, please. The data come from the CT scanner, and automatically, when the folder is closed, it goes to another machine that runs some software provided by the American College of Radiology, which extracts demographic information and certain other key tags in the header, and then builds a file that could either be transmitted directly then on a transactional basis to the ACR dose index registry, or it could be queued up and transmitted at 1 in the morning or 2 in the morning, whatever the facility feels like they want to do. And then the reports will come out semi-annually, and then they can compare, and we'll go through a couple of those so you can see that. As of March of 2013, there were over 600 facilities that had registered with the registry, and about half of them were fully active in participating. We have, at that time, roughly 3 million exams and 6 million scans. Many exams, of course, have more than one scan in them. So it is rapidly growing and gaining in participation. We'll discuss a few more other things about that in a minute. Next slide, please. So you can see from the slide that this represents the representation of the facilities, at least in the United States. And you can see that there are distributions, as you would expect, in high, densely populated areas of the country. And also, if you see on the right, it shows the distribution by practice. And in fact, the community practice is the largest area of participation right now. In addition, you can see the 4 regions. Those are the 4 U.S. Census regions, and that's the reason that they were picked this way. The South is a little bit more participation than the others, but in general, they match up fairly well. Next slide. Well, some of the challenges that we faced in implementing the dose index registry had to do with compatibility. Not everybody calls the same thing, and that that presents a rather large problem if one wants to compare their chest, abdomen, pelvis to the rest of the data in the entire DIR. In addition, nowadays the CT scanners modulate the beam as the X-ray tube goes around the patient, and hence there is a difference in what the dose index might have been set up for and compared to what actually happened. And so we do have a method now to scale the dose indices so that they provide a better estimate that depends on the patient's size. In addition, some of the older scanners don't provide the structured dose report. For those scanners, there are third-party products that can extract the information and build the proper header. Next slide. Now, as I said, one of the things that we had a problem with at the very early part of the DIR was the naming of things. We extracted in the early days of the pilot from exams that looked very much like they were head CT scans, and there were over 1,400 different names. When we went to just let's do a head without contrast, we thought that was going to be a lot easier. There were still over 1,000 different names. So we felt that we had to do something to normalize this, otherwise there would be no way to compare your institution with the rest of the DIR. So the technique we have chosen is we're using a ontogeny that was developed by RSNA called RADLEX. And so the facilities can keep whatever name they like, Dr. Jones' favorite heart scan, for instance, or something, but then it will be mapped to a standardized terminology so that these comparisons can be made. We've also used an external vendor, that is RadMaps, if the facility doesn't want to do the mapping procedure themselves. Next slide. And here you can see some of the types of things that occur. On the far left is the facility's particular name for a particular study. And then as you can see, as you go over to the next column, now the terminology becomes standardized and is assigned an ID number. This then allows the comparison that we talked about to take place. Next slide. The other item is the size-specific dose estimate. The way this works is that the data are, in addition to the dose index data, the localizer, either the AP localizer or the lateral or both, are also sent to the DIR. And then from that, the data are automatically are sized so that we can calculate the SSDE. Next slide. So the SSDE is the size-specific dose estimate. It was a technique developed by a task group of the American Association of Physicists in Medicine. So the images come in, and an algorithm is used that was developed at Duke, in which the size of the patient is determined and made that into an equivalent circle, and from that the estimate can be made. Next slide, please. So the thickness is measured, the effective diameter is calculated, and then using the techniques described in the Task Group 204 report from AAPM, the data are converted. So instead of a standard dose index like CTDI volume, instead it's reported out as the size-specific dose estimate. And this is probably the way things are going to be active in the future. Next slide, please. So the benefits are that the facility at any time can look at all of its own data. So if it chooses to do a quality project or some other technique, the data are available all the time. And so they would not have to go to another source to try to get dose index information. And then the report comes out semi-annually now. That will likely be more frequently in the future. But for right now, it's a semi-annual report that allows them to compare their specific dose indices to the rest of the DIR or their region or their zip code or whatever they choose to do. Then when they do that, then they can say that, oh, if our value was a little bit higher, then is that something we want to do? Is there a reason why we're higher than what the average is? And we'll go through a couple of those in a minute here. Next slide, please. The data can either be looked at through a box plot, and that's on the left. The top and bottom of the box are the 75th percentile and 25th percentile, respectively. The hash marks at the top and the bottom are the range, the lowest number and the highest number. And then in between is also the average and the median. We have found over time that the median has been a more reliable indicator, and so therefore most folks are using that as an indicator. In addition, as you see on the right, you could look at one exam over time and see how is it varying over time. And there are reasons why it might be different from time to time. And in fact, it might be different from scanner to scanner, depending on the generation of the scanner. Next slide. So the reports come out every 6 months, includes the size-specific dose estimate, and then eventually this will be an online web service so that at any point in time the facility could generate their own reports, as their own data, as well as the reports of the entire database. Next slide. So this is a few studies that have been taken out, and you can see that there is it is interesting. The three values are the 25th percentile, the median, and or 50%, and the 75th percentile. And you can see that, in fact, these are for size-specific dose estimates, and the range of numbers and the range of values is considerably reduced than it was when we used to use just the straight index CTDI-vol. Next slide, please. So the red line here is the median for the facility, and you can see then that there are different ways to look at the data. And in this case, this facility's median was below the median for all different ways to look at the data. And so therefore, that would tend to indicate that maybe they are happy with that. Or if it was too low, perhaps their images might be a little bit noisy than others, and that might be something that they want to address. On the right is a histogram in which the facility can compare their particular distribution of dose indices to the dose index registry. This is very useful in determining outliers. Sometimes there are very high values, and in looking at these, many times it's because the procedure was changed. Patient was on the scanner. The techs called the radiologist over and said, look at this, and then they decided to do more scans. Or if they added on a perfusion study to a head CT, then that could change the dose index data quite a bit. But the point is, they didn't close out the file and then open another one. And nobody, I mean, this is reasonable practice. So therefore, that helps identify these outliers, and in the future, then those can be taken care of in the database. Next slide. So the preliminary results were based on data from July to December of 2012. There were 322 facilities that were participating. Over 1 million CT scans with standardized names were used, and on 151 studies. 18 of those studies had at least 10,000 observations, and then 151 with over 100 observations. So these are the data for 4 of the most popular scans that did have size-specific dose estimations. You can see that the range still has a rather substantial order of magnitude difference, and that's usually because of the fact that either the lowest number was a bolus testing, a circulation testing with a bolus or something like that, which is low, or they added on another test during the same exam. But you can see the distribution between the 25th percentile and the 75th percentile is right around about the order of about 10% of the median. And that's certainly a lot better than what we saw at the very beginning of the use of these dose indices some time ago. Next slide, please. These are the CTDI-vols, and you can see contrasted to the previous slide, there's a much larger range of dose indices than the size-specific dose estimation. So we think that this does prove that this is a useful thing to do, and will probably be the way that we will be looking at these dose indices into the future. Next slide. So you can see the distribution here. You see to the far right where there are some clear outliers, not many of them, but enough that they do affect the the presentation of the range. And that's why we should be very careful when quoting the value of the range of dose indices for a given study. There are legitimate reasons why there might have been a dose index in that standardized report. However, it was because of the way the practice handled a particular case. Next slide, please. This is the distribution of the dose linear product. The two indices that we do use right now are the CTDI volume and the dose length product. The dose length product does express a little bit different of an index because it tells you about how much anatomy was covered, and the fact that for some of your patients that are shorter than others, certain parts of the body for sure it'll be a longer scan, and therefore the amount of radiation used during that study would expect it to be higher. So there are some, we are providing both of them now, and some facilities are looking at their data using the dose length product, and others are using the size-specific dose estimate. Either one, both of them give you a picture of things, it's just that the pictures are slightly different. Next slide. As you can see, the distribution from the SSDE compared to the previous slide is a lot narrower. And that's because we have now the ability to account for the fact that patients don't all come in one size. There are many different ones, and then this reflects more what was actually done on that patient when the imaging study was done. Next slide, please. So you can see here how a facility would compare for a variation across different facilities, different types of facilities. So the key thing here is that the facility wants to compare themselves to those facilities in the dose index registry that most closely match their particular practice. So whether it's the size of the practice, the type of patient populations, rural versus metropolitan, academic versus community, et cetera. And so that is an interesting value. They are different right now, and we think that as more and more facilities utilize the dose index registry, then that variation will tend to become smaller and smaller. Next slide, please. So the benefits are that the facility then will have a good handle on what their dose indices are, and therefore they can answer a question from a patient that's concerned about a study that yes, they participate in the dose index registry, they have an ongoing process to see what their amount of radiation used is compared to the rest of the participants in the registry, compared to the rest of the participants in the United States, for instance. So that becomes important to patients, and it's consoling to patients that someone is watching out after that. Typically, the way in which most facilities are doing this is that when they get the report, they will then select certain studies to take a look at, and then periodically, either a radiation safety committee or a standalone committee. At our institution, we happen to use a standards committee. We will look at the studies that are relevant for that particular meeting. Now, in our case, we also break them up into to working groups of either body CT, neuro CT, or MSK CT. And they will take an in-depth look that if our dose indices are higher than the median for the DIR, then they will take a look at that and make some suggestions. It'll be a team of 3 radiologists, a physicist, and a technologist that get together and choose what parameters should they think about changing in order to get the dose index lower. That will then be tested to make sure that it's working in real life, and then the implementation can be made. So the point is here that by using the dose index registry, there's an ongoing observation and analysis of the amount of radiation the facility is using. In addition, this has been, the use of the dose index registry in this way has been certified as a part for physician quality improvement project for maintenance of certification. And in addition, it has been approved by the National Quality Forum and is available as a PQRS measure or a measure for meaningful use. So having such an activity does allow a lot of different things to be taken care of at the same time. Next slide. We are now expanding the DIR. In fact, it's very active right now. The initial pilots are just underway for CR and DR. So we expect that will happen by the end of 2013. Similar kind of a setup, that is that when the study is closed out in the room, the radiographic room, then the dose index information goes to the same machine, of course, that the facility might have been using for CT. The data are extracted and then sent up to the registry. Following CR and DR, we will likely begin to move into fluoroscopy. Fluoroscopy is a little bit different because of the nature of the structured dose report. In parallel, we are also looking at what could be done for nuclear medicine. That's a little bit different practice because of the fact that about the only thing that one can change is the administered activity. The rest of the components of the dose have to do with how long the radiopharmaceutical stays in the patient and where it is distributed. But we do think that there are some very interesting ways to approach this so that facilities could compare their practices with other facilities. And it's very important to understand also that this takes all the scans, in this case of CT, all the scans that are done on that particular scanner. So there's no bias in terms of sampling bias or something like that. You're taking everything. And so you therefore know what the real state of your practice is. And you could implement a change, for instance, to lower your CTDI for head CT without contrast, and then measure for a while, and then go back and see how well you did. And then if you wanted to do that, then or after you did that, you might want to continue to refine that a little bit more, or you could move on to another scan. The point is that this is a continuous process in which the facility is always aware and looking at what their radiation levels are like. And that's a truly changing culture for practices in the United States, but certainly is going in the proper direction. Next slide, please. So right now, participation is, of course, voluntary. When you join the registry for the ACR, you can also join into all of the other registries. And the participation does have an annual fee, and the fee is based upon the practice size. Thanks very much.